Hello everyone, my name is Hipólito Magdiel Venegas Montaño and I'm going to talk about Tlalpujahua clay subject to an ultrasonic fatigue test under 3-point bending loading. I'm so glad to be here and share this project with you. Clay used come from a little town in Mexico called Tlalpujahua, whose people specialize in building artifacts made of clay. Clay is constituted by granular mineral capable of becoming ceramics once it receives a heated treatment. In this study, a small brick made of Tlalpujahua with a specific dimension is thermally treated in an oven at different temperatures, 500, 750, and 1000 Celsius degrees. Then, ultrasonic fatigue test is applied to each sample, under the modality of the 3-point bending. Then, a test consists on holding the brick by its two ends so a vibration load is applied at the center, generated by an aluminum alloy oil. The fatigue endurance is determined and the fracture surface are analyzed to identify the initial trends related to crack and the fracture spreading through the material. The next section is clay preparation and ultrasonic machine. Samples of clay were made in 3D printer, molded as shown in figure A, and let dry at room temperature. Then they were thermally treated for 5 hours in an oven at fixed temperatures of 500, 750, and 1000 Celsius degrees. In figure B, a prismatic clay is shown after being thermally treated. A homemade platform was built in 3D printer to fix and attach the clay sample. Figure C shows the mechanism to decrease and increase the height of the performance, and in the same way it decreases or increases the pressure of the clay sample. The pressure is controlled with a pressure sensor showing in the figure D, and the complete support is showing in the figure E. The functionality of the ultrasonic machine in the figure F is to generate vibration load in the surface of the clay brick that is transmitted in an oil manufactured for the aluminum alloy, which produces a displacement depending on the voltage of the ultrasonic machine. In this case, the voltage was between 10 and 70 volts, provoking a displacement of 0.007 to 0.012 millimeters. Using the finite element software, we obtain an approximation of the formation behavior of the clay sample under different forces and different displacement. The forces and the displacement are acting in the center of the sample, where the aluminum oil acted once the machine is started. It was over a slice of aluminum where the oil acted. The slice was added because the dimension of the oil was smaller than the sample. It was possible to use all the surface under the forces of displacement with the slice. The considered values for these forces were selected in a range between 5 to 20 newtons, and the displacement in the range of the 0.005 to 0.033. As a result of the discussion, the result of the infinite element software were taken in consideration to determine the force and the displacement necessary to break the sample with adequate resonance vibration, which are presented on the table 1. In figure K and L is shown this behavior when the sample were under forces. The ones that were thermally treated at 500 and 750 present a highest deformation. Meanwhile, the samples were under displacement to one that was thermally treated at 1000 Celsius presents the highest deformation. It is important to mention the ultrasonic machine started in pulses of 10 volts, and it was increasing by 1 volt every 5 seconds until it reached 17 volts. As a conclusion, this prototype can be treated for further testing since it has a lot of variables, such as initial pressure, displacement to the voltage, temperature, and the dimension of the sample. This study was helpful to find the two main following insights. It is necessary to focus on the forces if the test is to be applied to samples that was previously thermally treated at 500 and 750 Celsius degrees, and if the test is to apply to the samples of thermally treated at 1000 Celsius degree, it's necessary to focus in the displacement. This is all. Thank you very much for listening.